Hey, welcome back. Fancy meeting you here. It's your favorite chemistry teacher. This video is going to be an explanation of topic 3 free response answers. Should be pretty fast. So let's get started. Okay, so the first question in 1997 asked to write the nuclear decay equation of Pu 234. So when you do this, you're just going to rewrite 234 94 Pu, and it says it goes through an alpha decay. So first of all, decay is going to mean draw an arrow. Alpha 4 2He. It's your alpha particle. Beta is 0 minus 1e. Gamma 0 0 with the upside down fishy. Okay, plus, and now you just need to figure out what the missing piece is. So according to the law of conservation of energy and matter, the mass numbers have to be equal on both sides, and the charge, and we call this charge because it's the number of protons, but protons can also be called nuclear charge. Okay, so 230, 92, and then you look up the element symbol by the 92, which is U. Okay, part B. Account for the fact that the total mass of the products in the reaction is slightly less than that of Pu 234. So it's saying when you add these masses together and you compare the mass of that, the mass of this is slightly less than the mass of your total. No, that's a lie. Mass of your products are slightly less than the mass of your reactants. Sorry about that. Okay, so the reason why that is the case is because of this thing called mass defect. Mass defect, when you have a nuclear reaction, some mass is converted to energy. So some of this 234 actually is released, a very small amount, the difference is not going to be huge, is released as energy. So it's not going to weigh exactly 234 on both sides. So anytime they ask you something about why mass is different on one side compared to the other, it's because of mass defect. C. Describe how alpha, beta, and gamma rays behave when they pass through an electric field. Okay, so they said positive, negative. Gamma's going to go straight through because it's neutral. The one that is negative is going to attract to the positive field, which is your beta. Remember, beta is 0 minus 1e. And alpha then is going to go towards the negative, because alpha is for 2He, giving it a nuclear charge of +2. Okay, D. Why is it not possible to eliminate the hazard of nuclear waste by process of incineration, so burning it? I would just say half-life is independent of environmental changes. So basically, if your half-life is 8 days, it's going to be 8 days regardless. Okay, so let's do 1991. Easy peasy. Okay, letter A. The mass of an atom of 4,2He is less than the sum of the masses of 2 protons and 2 neutrons and 2 electrons. So they're saying helium is less than the mass of 2 protons plus 2 neutrons plus 2 electrons. So if we think about this, they're trying to trick you, throwing in the electrons. Electrons do not affect the mass at all. So it should have a mass of 4 on both sides. And again, just like part B of the first one, mass defect says some mass is converted to energy. Great. Okay, part B. Alpha radiation penetrates a much shorter distance. So alpha particles are the weakest. They have the weakest penetrating power. Because they are large in comparison to like beta and a gamma. Alright, C. Products from a nuclear fission of a uranium atom, such as SR90 and CE137, are highly radioactive and decay by emission of beta particles. So if you're asked to explain why things go through a nuclear decay, the goal is that if things have a proton to neutron ratio that is not 1, that's usually greater than 1, well, always greater than 1, it's going to go through nuclear decay. So the goal is to, by emitting a beta particle, the proton to neutron ratio becomes closer to 1. Perfect. Okay, letter D. Nuclear fusion requires large amounts of energy. Oh, sorry, I should probably not shake my leg. Requires large amount of energy to get started, whereas nuclear fission can occur spontaneously. Okay, so fission is when you have a big particle split into smaller ones. Fusion, you have positive nuclei merging together. So you guys know that bringing two positive nuclei will repel each other. So it takes a lot of energy to overcome the repulsive forces. Alright, so that means you need a really high temperature and a high pressure to get it going. Okay, that's it.